Hello everyone, my name is Amrita. I am from CSE department of AKGEC. Today I am going to explain Arithmetic Logical Shift Unit of COA subject. So these all are the outline of my lecture, Introduction to ALU. So we will start with Introduction to ALU, then we will see what are the arithmetic circuit, logical circuit, shift operation and design of ALU. So these all are the main outline of this lecture. So firstly we will understand what is the meaning of ALU and what is the role of ALU in our computer system. So arithmetic logical unit is a key component of computer's central processing unit. The ALU perform all arithmetic logical operation in the computer. So ALU is a part of our CPU. For example, we have, this is the CPU and it is divided into three parts. First one is your control unit, second is your registers, and third is your ALU. The work of ALU is to perform all the arithmetic and logical operation. Fine. So how it will perform this operation? So we have a logic circuit for it, and we have combined all different type of circuits. For example, we can combine arithmetic, logical and shift operation we can perform here. So we will see how this logical circuit, how this arithmetic circuit will work. So firstly we will see arithmetic circuit. Arithmetic circuits are fundamental blocks in digital system and are used for arithmetic operations such as addition, subtraction, multiplication and division. So all the arithmetic operation will be performed by the arithmetic circuit. So this is a separate circuit which can perform more than one different type arithmetic circuits, the arithmetic operation. So you can see here, this is the arithmetic circuit. Now this is the 4-bit arithmetic circuit, because we have 4 bits here, A0, A1, A2, A3 and A4. So it is going to perform the operation in the two numbers A0, A1, A2, A3, B0, B1, B2 and B3. Okay, so it will perform operation on the A0 and B0 or A or B. Fine. So we should see here we have adder here. The work of adder is to add the number. For example, if we want to add two numbers A0, B0, so we will give a full adder and we can add A and B. Now we have to add the numbers, we have to separate, because we can done more than one operation with the help of arithmetic circuit. For example, if we want to add A plus B, so first number of A is same, but we will give in the second number we will give B. If we want to perform subtraction, first number is A but second number will be B bar plus 1 with the complement. So if we want to perform different for example, if we want to increment A plus 1, if we want to decrement A minus 1, so in this case what will happen, the value of A will be same, but the difference between the B bar plus 1 minus 1. So we can see here second number will be changed always. So we have to give a multiplexer choice here, because A will be directly connected to the full adder, but B will be connected through the 4:1 multiplexer. In this multiplexer, because the size of the multiplexer is 4:1, what it means, we have two selection lines here. So firstly we will connect and we have 4 inputs here and one output which is connected to the full adder. So we can change the different inputs from the multiplexer. For example, if the value of the selection lines will be 0, 0, then the 0 input will be selected and 0 input is connected with the B. So we will get here B. So then A plus B will be performed. And one more thing, because we have full adder here, so we have 3 inputs here, because full adder will have always 3 inputs. So one is the carry input and 2 are the to are the other A and B inputs. So if the carry value is 0, then we will perform here A plus B. If the carry value is 1, then we will perform here A plus B plus 1. This is the difference between these two operations. Now again, now in the next case, when we give the selection line values 0, 1, then the B bar will be selected here. So if the carry value is 1, then the operation will be A plus B bar plus 1. If the carry value is 0, then the operation is A plus B bar. So always operation will be changed by the help of selection lines. Now we can see here, when the selection line value is 1, 0, then what will happen? In the case of 1, 0, the second input will be selected here, and the second input we have given here 0. When we provide here 0, then here we will not get B, we will get here 0. And if the second input of the full ladder is 0, then what will get here? A. If the C in is 0, if the C in is 1, then we will get A plus 1. So in the next case, when we give 1, 1, then we will have here 1. So when we give 1, 1, then we get here 1. Then the operation will be performed A plus 1 and only A. Because when the carry value is 1, then value is A minus 1 plus 1, and the value will be A. Now the question is how we get A minus 1. How we get? Okay, this is the circuit of arithmetic circuit. The work of the arithmetic circuit is to perform all the different type of arithmetic operations. So we have here one full adder which can add two numbers. In this case we are performing A plus B. A can give directly to the full adder, but B will be given to the full adder through the multiplexer. What is the reason behind it? Because when we perform A plus B, then this is the addition operation. If we are performing subtraction operation, then we can give here A plus B bar plus 1. If we are applying increment operation, then A plus 1 will be there. If we applying decrement operation, then A minus 1 will be there. So we can see here A is the same in each and every operation, but the value of second operand will be changed every time. So we will give a multiplexer here so that we can change the second input into the full adder. When we give 0, 0, then we can see here we can 1, 0, then 0 will be there. If we give 1, 1, then 1 will be there. So these are the different inputs which we are going to give in the arithmetic circuit here, right? And we will have different operations here. So we can see in this table, we can see here, in this case you can see here, when the selection line value is 0, 0 and C in is 0, then what we will have? A plus B means addition operation. If we have selection line 0, 0 and C in value is 1, then on the output we will get multiplexer output B, and we will have D is equal to A plus B plus 1, which is known as a add with carry. Now in the next case 0, 1, C in 0 and B bar is there. D is equal to A plus B bar. What it means? Subtract with bar. In the next case we can see here when the value of 0, 1 selection line and the C in value is 1, then A plus B bar plus 1 is subtract the operation. And then in the next operation, when we have selection line value 1, 0 and C in is equal to 0, so then we will get here 0 output of the multiplexer and we will have operation A transfer. When we give 1, 0 and C in ki value, when the value of C in is 1, then we will get 0 again here, and the D is equal to A plus 1 because we have added C in value 1 here, then it is known as an increment. The most important case is here decrement operation, A minus 1. How it is possible to decrement? Because now we are adding here 1, because 1, 1 on the 1, 1 the selection lines will be selecting 1. For example, in this case 1 will be selected from here. Now we can see here, if we add 1, A0, A1, A2, A3 is there, and we want to add 1, 1, 1. What it means? This is the complement of 0, 0, 0, 1. So we are not adding 1 here, we are adding the complement of 1 here. What it means is which is equal to A minus 1. That's why it is known as a decrement operation. So in this case we have decrement operation, and next case when the carry value will be 1, then A minus 1 plus 1, which is equal to A. So D is equal to A. So we can see here in this arithmetic operation, arithmetic circuit, we can perform 8 operations, different 8 operations simultaneously. Which operation we want to perform, we will give the value of the selection line accordingly. Fine. Now this is the arithmetic operation. Now the next is the logical operation. In the logical operation, you can see here, this is the multiplexer. Because now in this case we have performed all the logical operations. So concept is same like arithmetic circuit, but in this case multiplexer is placed here, and the and different type of logical gates are connected here with the multiplexer. So we can see here in the 4:1 multiplexer we have 4 inputs and 1 output, and we have 2 selection lines. Fine. Now from the first input, AND gate is connected to the input. In the next one, OR gate is connected in the input. In the second, XOR gate is connected to the input. And the third, AND gate is NOT gate is connected to the multiplexer. Now, when we will give 0, 0, what we will have in the E? We will have AND operation between the 2 inputs A and B. So we will have A and B. When the value of selection line is 0, 1, then we will have A or B. Then when we have selection line values 1, 0, then we have XOR gate. So A XOR here. When we have 1, 1, then we have complement gate. So E is equal to A bar is there. So in this way we can perform all logical operations. So firstly we have seen how we can draw or design a arithmetic circuit, and the next slide we have seen that how we can design a logical circuit for logical operations. So now next is the shift operation. Now the third different type of operation in the ALU is performed is shift operation. So shift operation can be of 3 types: logical shift, circular shift and arithmetic shift. Fine. So we will see one by one what it means, what is the meaning of logical shift, why we use circular shift, arithmetic shift. So we will see with the one example. This is a logical shift, because everything is in the computer is in the form of 1 and 0. So logical shift is performed on the register, and it will shifted by 1 digit. For example, you can see here this is the number, and in this number, this is the left logical shift. So the whole digit will be shifted to left. For example, you can see here 0 will be here now, 1 will be here now, 1 shifted left, 0 is shifted to left, 0 again shifted to left, 1 is again shifted to left, and 1 is again shifted to left, and 1 is again shifted to left. So this place will be empty. Now this place will be filled by the 0 number, which is also known as a serial input. So we can give 0 here. So only 0 will be inserted here, never we can give 1 here. Fine. In the right logical operation, what it means, now the shifting will be done in this side or right direction. For example, you can see here this one will be lost, then next one will be come to here, next one will come to here, 0 will come here, 0 will come here, 1 will come here, 0 will come here, and 1 will come here, and this place will be empty. Now we can insert here 0. Okay, so in this way we can perform logical shift operation, and this logical shift operation can be of 2 types, left and right side. In the empty place we will insert 0 in the logical shift operation. Now next is the circular shift. Circular shift operation is different from the logical shift operation. How it is different? You can see here this is the MSB and this is the LSB bits. This is the number 10101. So when we have circular left shift, when we shift the number, then this number will be lost in the logical shift operation. But in this case, this number will not be lost. It will be replaced in the LSB. So this is also known as a circular. That's why it is known as a circular. So you can see here 0 will be placed here, 1 will be placed here, 0 is placed here, 1 is placed here, and this one will be placed here in this particular place, which is the place of LSB bit. So this is known as a circular left shift. Now the circular right shift, what it will happen in the right shift? When we perform right shift, what will have? You can see here, this is the LSB and this is the MSB. In this case, the shifting will be done in this side because we have right shift. So if this one will be replaced in the MSB bit. So you can see here 0. This one will be placed in the MSB bit, and 0 will be placed here, 1 will be placed here, 0 will be placed here, and 1 will be placed here. So in this way, we can perform circular right shift. Now the next is the arithmetic shift operation. You can see here arithmetic shift operation. In arithmetic shift operation, left arithmetic shift is same as logical shift, but something is different in the arithmetic shift, because this arithmetic shift operations is done in the signed binary number. So MSB bit will be here signed bit, because in this case we are performing the shifting operation on the signed number, but circular shift and the logical shift was performed on the unsigned bit. So there is no problem of the signed bit, but in this case we cannot change the signed bit. That's why we are using arithmetic shift. So we can see, when we see the right arithmetic shift, what will happen when we shift the digit in this direction, then this is because this is the signed bit, will be copied into this place, because this one will be shifted and again copied also. So both places we will see here 1 will be placed here. So the sign bit of the number will not be changed. But in the case of left shift, you can see it, when we shift in this way, then the MSB bit will be lost. So how can we find out this is a right number or not? Because we have lost the sign bit. So we will use XOR gate for here. In the XOR gate, we will give this and first and this bit. If the value of both bit will be 1, what it means? There is some problem, there is an overflow problem. If both bits are same in the XOR gate, what it means? The output will be 0. Then there is no overflow case. But if these two bits are different, what it means? That obviously when we lost the MSB bit, then the sign will be changed. So then can be a possibility of overflow here. So in the case of left arithmetic shift, we have to check overflow case also. So this is the arithmetic shift operation. Now these all are the operation we have studied. We have studied about the arithmetic shift, we have studied about the logical shift, and we have studied about the circular shift, and these shift operation will be performed by the ALU. Now we will understand what is the meaning of ALU. ALU will perform all the arithmetic operation which is performed by the arithmetic circuit, all the logical operation which is performed by the logical circuit, and shift operation. So we can see here, this is the design of the arithmetic logic shift unit. In the one stage of the arithmetic circuit is connected, and one stage of the logical circuit is connected, and this is the shift right and shift left. Now how we can design it? We will use a 4:1 multiplexer, where we have 4 inputs, 0, 1, 2 and 3. Fine. And we have 2 selection lines, S2 and S3. Fine. So when the value of S2 and S3, what will happen when the value of S2 and S3 is 0, 0, then what will perform? Arithmetic operation will perform here. If the value of 0, 1, then logical operation will perform. If the value of selection lines will be 1, 0, then shift right will be performed. If the value of selection line will be 1, 1, then shift left will be performed. So in this way we can perform different operation with the help of ALU. So you can see here arithmetic logical unit is a combination all the different type of circuit which can perform arithmetic, logical and shift operation. So this is the table, you can see here the table also. So these all operation can be performed by this ALU. Fine. So we can see here the main 8 operation can be performed by the, these all are the 8 operation which is performed by the arithmetic circuit. Then these 4 operation which is performed by the logical circuit, and these 2 operation which is known as a shift right and shift left is performed by the ALU. So these all the different type of operation will be performed by the ALU, and so this is why this in this way we can design ALU. So this is a very important part of our CPU. It will perform all the different type of mathematical operation in the CPU. So I think you will understand it very well. Thank you.